Hey guys, and welcome back. In this video we'll be talking about the assembler in opcodes. But before getting to that, let me correct myself on some mistakes I've been doing out of bad habit. I've been calling these instructions or the mnemonics as opcodes, which they're not actually the same thing. So let me just type something here fast, something you've been seeing forever, something like this. So we'll either be calling this a mnemonic. Mnemonic meaning is something more human readable. So this load A, which means they load the accumulator. So mnemonics means human. So we abbreviate this accumulator. Type it right. So all we're doing pretty much is shortening all these letters so it's more human readable, like. If you program assembly x86, you have like move, add, and so on. It's the same thing, exactly the same. So just this means load A. This means store A or the accumulator, and so on. So either this calls the mnemonic or a instruction, and that's what I'll be calling this from now on. So now you have that out of the way. So what's an assembler? Well, all assembler is another program that's gonna run our code and make into the machine language. Because if this is not, it's not really machine language. But let's assemble and run, so it works. So let's click this hex dump. Oh, and also, as you see, it has all these random numbers. You don't know what it means, but it also has a disassembler over here. And as you see, side to side comparison, our disassembler, that's why one of the reasons I like this emulator so much. He actually has also the hex dump over here and has the address and so on forth. So I like this version better. So, and it's really separated. So let's just close this. So let's go through this. So as you can see over here, it says even how much it has to jump from address, but let's go back to here. As you see over here, you have LDA, the literal value 02, and if you see that, it's representing LDA with the value 09. Not my A9, my bad. A9 and A2, so right over here, the exact same thing. So the assembler is taking this mnemonic, it's converting to this, the actual opcode, which means operation code. So the chipset is gonna look at this LDA, like it's gonna convert to this operation code so it can execute. So when it sees this value A9, the computer knows it's supposed to load this value 2 into the accumulator. And here you have 8D, which represents the store the accumulator, the value in the accumulator into this location 200. It's right over here. For example, 2561, something's more different. So 61, the high is first, and then 25 is the next one. Anyway, so 200 it's not 2000. It was 0. Assemble and run. As you can see, it's gonna be the exact. Oh, let me reset. LDA hashtag 2. Assemble, run, disassemble. Okay, so here it is, 02. So this is the low is gonna be the second one, and the high is gonna be the first. So just to show you guys that it's the same, let's just change the value over here. 3, 4, 1, 2. Let's see what happens on our pixel display. Oh, it works. So now let's go to the disassemble. Oops. excuse me. As you see, it's exactly the same. So 2, 3, then you have high and low, and so on. So it's behaving exactly as expecting, low A, 80, and so on. So now, this is the opcode, the operation. So if you're ever wondering why, even though we store this when you put this pound sign over here, the pound hashtag or number, whatever, if we put the number 2, it actually means the literal value 2. It's actually number 2. If you take out the number 2, yeah, that means the address. So if we, let me just press enter so we can assemble again. Assemble, run, and this time you see there was no pixel over here because this is actually referring to the address. So low, the address 2. So like I said, if you see an example, the previous videos 0, 1, 2, so load that address. And if you come here to the disassembler, let's go back over here. So instead of A9 like you had before, it's actually 05 and 02. So even though this instructions LAD, that's the difference why I was wrong referring to this opcodes instead of the instructions, because this is gonna so the assembler is gonna go through here, see that there's no pound, so it's an address, because there's no way of the computer really knowing what's inside its storage as actually an address or a value. So the difference is between the opcode. So okay, so this is 05, this is not it, the actual value 2, this is the address 2. Then you come here to LDA 03, this is actually the value 3, not the address. So the assembler is like, okay, this is 09 because this is actual value, and this is 05 because that's an actually address. So that's gonna be pretty much it for this video. So see you guys in the next one.